In this simulation, we're modeling an ideal case of a small amount of liquid that evaporates. So the liquid is here and evaporates into a vacuum when this stop is removed that allows the piston to move to the top. The piston is assumed weightless. And the system container is assumed to have no heat capacity. So when we do an energy balance, we're only doing energy balance on the liquid and the vapor that ends up at equilibrium. We can change how much liquid we start with by the slider. We can also change the initial temperature. And then when we hit the play button, the slider is removed, the gas evaporates to get to vapor-liquid equilibrium. And so the starting temperature and the starting amount of liquid affect the final temperature and the final amount that evaporates. The amount that evaporates has to be the amount required to fill the volume to obtain vapor-liquid equilibrium. So whatever the saturation pressure is at the final temperature. So we're using both energy balance and saturation pressure as a function of temperature. So let's look at the simulation to observe the behavior. So here's the interactive simulation, and we start 80 degrees and I select play. Then the final temperature is on the right, 74.8 degrees, and it shows that we started with 25 grams, we ended up with 24.75 grams, so very small amount. Only 0.25 grams evaporated. Now I can reset and I can make the temperature lower. When we start, I can make the mass a lot lower, and now we get a bigger temperature drop, and we've in this case evaporated 1/10 of a gram. And so the idea is to try and understand the relationship between vapor-liquid equilibrium and the energy balance for this system. On steady state system, and the heat of vaporization comes from cooling down the liquid and vapor.